All right, guys, we're going to look at 4.3, lesson 4.3, and we're going to look at some extra examples on the identity properties. So the first thing we're going to look at is verify the polynomial identity. All right, if you remember from the task, the polynomial identities can be verified by making the left side equal the right side. So since this side is already simplified, we're just going to simply work with the left side. So let's bring down the a squared plus b squared. And then I look at this, and I know this is a difference of squares. So I'm going to bring it down, but I'm going to multiply. So I'm going to have a times a is a squared. And then because it's a difference of squares, the middle terms cancel out. So minus ab and plus ab cancel. And then b times negative b is b squared. And again, that's one of your identities as well, a difference of squares. All right, so then we're going to do a squared times both terms in this binomial, and then we're going to do b squared times both terms in this binomial. So a squared times a squared is a to the fourth. A squared times negative b squared is negative a squared b squared. And I always put my variables in alphabetical order. That's a good habit for you to get in. So when I do b squared times a squared, I'm still going to put a squared, b squared. So it's just a good habit to always put them in alphabetical order. And then b squared times negative b squared is negative b to the fourth. Now I can see that I've got a plus and a minus of the same thing. So those cancel. So I have a to the fourth minus b to the fourth. And we can show that that is the same as the right side. So once we show that the two sides are equal, we have verified the polynomial identity. All right, let's look at another example. All right, same kind of thing. This side is already simplified, so we need to work from the left side. So we're going to do x squared times this whole polynomial. So let's just write it down. It's going to be distributive property. But this will help us not lose anything. And then we've got y squared, and we're going to multiply it by everything as well. All right, and we want to know that that equals this. All right, so x squared times x to the fourth is x to the sixth. X squared times x squared is x to the fourth. So don't forget the negative. So it's going to be x to the fourth, and I still have my y squared there. And then I have x squared times y to the fourth. And again, when you've got multiple variables, always put the variables in alphabetical order. All right, so you've got y squared times x to the fourth. So that's x to the fourth y squared. So when we change the order, we're using commutative property, but it's just an easier way to keep track of things. All right, and then I've got minus x squared, and then y squared times y squared is y to the fourth. And then I've got y squared times y to the fourth. Same base. Remember, you add exponents, so that's y to the sixth. All right, now we have a negative x to the fourth y squared and a positive x to the fourth y squared, so those cancel. And we have an x squared y to the fourth and a negative x squared y to the fourth, and those cancel. So we have x to the sixth plus y to the sixth. And that is what we started with. So we have, again, verified this polynomial identity. All right, it says use the given polynomial identity to find the indicated variable. Or, sorry, value, not variable. All right, so we've got a plus b quantity squared equals a squared plus 2ab plus b squared. So this is one of our identities, and they're saying use that to prove 32 squared. Okay, so let's say we've got a and b. So let's say a plus b, and we need something that equals 32. So let's just make it easy. Let a be 30, b equal 2, and let's see if we can prove this identity. All right, so we're going to do 30 plus 2 squared. Does that equal a squared, which is 30 squared, plus 2. A is 30, B is 2, and I'm going to erase that. And so that was the middle term, and then I've still got plus b squared. So b squared is 2 squared. All right, so I've got 30 plus 2. So 30 plus 2 squared. So I'm going to have, this side's going to be 32 squared, and 32 squared is 1024. All right, so now I'm going to do 30 squared. 30 squared is 900. And 2 times 30 times 2 is 120. And 2 squared is 4. So this would be 1020 and then 1024. So those do work. So you can see that we use the indicated value to prove this identity does work. Okay? All right, let's do the same thing with this one. Use the given polynomial identity to find the indicated value. All right, so we're doing a difference squared this time. So if we think about 98, that could be 100 minus 2. 100 minus 2 is 98. So let's plug in 100 for A and 2 for B. So if we do 100 minus 2 squared, and let's do 100 squared minus 2 times 100 times 2 plus 2 squared. All right, so 100 minus 2 we know is 98 squared. 98 squared is 9604. And then 100 squared is 1000. No, it's not. It's 10,000, sorry. And then 2 times 100 times 2 is 400. And then plus 4. All right, so we've got 10,000 minus 400 plus 4. And that gives us 9604. So again, that proves that the identity works, and it gives you, and it helps you find the indicated value. All right, use the given polynomial identity to find the indicated value. This time they're giving you 2 numbers. So let's plug them in and see what happens. All right, so we're going to say A is 51 plus 49, and then 51 minus 49. Does that equal 51 squared minus 49 squared? All right, so 51 plus 49, that equals 100. And 51 minus 49 equals 2, so that's going to be just 200. And then if we do 51 squared, that's 2601. And 49 squared is 2401. And 2601 minus 2401 equals 200. All right, so that works as well. And what they're wanting you to see is that if you know these identities, you can find the answer easier using one side of the equation than the other side. So for this one, if you did not have a calculator, this side would take a few minutes to calculate out. But on the left side, using your identity, you know, 51 plus 49 easily equals 100, and 51 minus 49 equals 2. This equals 200. This could easily be calculated without a calculator. So that is just useful information and a way to use the identities. All right, if you have any questions, please let me know.